get started. Now, first thing I want to do is I want to talk about how I'm going to do this section, okay? I do go off the beaten path a little bit, so I'm going to take my handy dandy whiteboard and I'm going to, let's see if I can do this. Let's see, I think it's under tools. Give me a second. I got cats playing right now, so if you hear something crazy, I got about 3 or 4 cats running around acting like they're teenagers. Well, that's not what I want. Give me a second. I guess y'all can hear these cats. I don't know if you can hear them or not. Okay, let me try this again. Text. It's supposed to be changing into a text window. Let's try it one more time. There we go. There we go. Okay. Unit 3 test will consist of 4 sections. This is your easiest test. You with me? 6.1, 6.2, 7.1, and 7.2. 8.1 and 8.2 will be on Unit 4 test. Let's see how many people will be confused over that. Anybody want to take bets?
3 people.
Nobody wants to take bets on it? Miss Woodward will text me or email me asking me she's confused.
Every time, Hubert.
Every time. All right, so anybody got a question on that?
Not me. Didn't mean to do that.
I don't know how do I change it? I'm thinking out loud. There it is. How do I modify it? It won't let me modify it. It won't let me move it either. I'm playing. I'm trying to figure out something. Okay, cancel. I don't have a cursor. I guess I can't move it. All right, make sure you got all that taken care of. Anybody got a question there? All right, let me go back and change my pen color. Change that to black. And I'm going to change that. Change this one. I'm going to change it to green. I'm going to make it translucent. And make it. There we go. There's still something wrong with my computer. I meant my program, because when I click on that, it's supposed to put a check mark there. And it doesn't do it. I'm still talking to IPVO and they're trying to figure out what's wrong with it. All right, so I'm going to go on to the next thing, and that is the handy dandy PowerPoint. Now, you want the good news or the bad news?
Give us the bad news first.
Bad news. Okay. I like bad news first. Bad news is we're going to have this test pretty quick. The good news is everything's done pretty much on what? Calculator. Okay? So that's a good thing. All right, here we go. We're getting started on 6.1. Okay. I don't want to do that. I'm going to go here. I'm going to get another page. Pick a color. How about gray? And then we'll use black. Okay, what we're going to be talking about here is what's called probability distributions. Everybody with me? Probability distributions. So write that down. Probability distributions. Probability distributions are distributions that are written like this. You got an event happening, and this is the probability of the event. Let's talk about World Series, or let's talk about this. Let's talk about zero. Let's say that a couple wants to have 2 children, 2 kids. What is the sample space for 2 kids? Boy, 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 girl, girl, boy, and what? Girl, girl. Now let's say that you work at a hospital, and let's say that the probability of boys on your floor, which is your pediatrician's floor, or whatever it's called, pediatric ward or whatever, the probability of a boy is around 0.45. You've calculated it. Therefore, the probability of a girl is what? Not a boy, is what? 0.55. Okay? So we're going to do a probability distribution on those 4 outcomes. These 4 outcomes right here. Okay? Because in chapter 1 and chapter 2, or unit 1 and unit 2, this is what you learned how to do. Okay? Now, in unit 3, we're going to put that in another form, and it's called a probability distribution. So, let's say the probability, let's go with the probability of girls. Okay, that's going to be our, and we're going to highlight that because that's the question would say, what are the probability of girls? Okay, that's going to be the question. It could say boys, it could say girls. How is the whiteboard working? Is it working pretty good? Any lag? Can y'all tell any lag?
No, it's good on mine.
Good.
I don't think there's any lag.
How about lag versus the document cam?
It's better. A lot better.
The
Yes.
whiteboard is better?
Yeah.
Good. It's kind of funny. I'm writing on my wall here with my little whiteboard wallpaper, and there's nothing there really. But when I look at the screen, there's something there. It's kind of funny. Anyway, the event of 0 girls. What would 0 girls be? I'm asking y'all. That's not
Boys.
all boys, which would be what? Boy, boy?
Yep.
I'm going to put boy, boy right here. And I'm going to put another column. Now, you won't see this in the book. I'm going to put probability number because I want to show you that middle column is not going to be in the book. I'm showing you how they come up with it. All right, what's after 0 girls?
1 girl.
1 girl. That would be boy, girl, and what?
Girl, boy.
Girl, boy. And then what would 2 be? 2 what? 2 girls.
Priority 1
That would
message
be-
coming in on
That
secure
would be
channel.
girl.
Okay, now we're going to figure the probability. Okay, so using your multiplicative law, because you want to find out the probability of a boy and a what? A boy. Did I say a boy or a boy, or did I say boy and a boy? I said and. What does and mean?
Multiply.
Multiply. So we're going to be using exponents here. So that's going to be 0.45 to the 2nd power. And since I've got 2 instances here, I'm going to look 2 times 0.45 times 0.55. And somebody tell me what the 3rd one would be. Come on.
0.45 times 0.55.
Now, what is it? 2 what? Not 2 boys, but 2 what?
Girls.
What's the probability of girls?
So 2 times 4.5.
0.55. So it'd be 0.55 to the 2nd power. Or 0.55 times 0.55. And I'm going to take a pink highlighter. And I'm going to highlight those 2 right there. And the reason I got 2 right here is because of the 2 instances right there. I want you to make sure you understand where I got that 2 from. Okay, now I need somebody to take your handy dandy calculator, and I need you to calculate those 3 things for me. While I'm going to erase this over here. I got to erase this. I'm going to erase the whole thing right here because I'm going to draw the new probability distribution. I'm going to draw it right beside there. So somebody give me the first one. Just round it to 3 digits. What is 0.45 to the 2nd power?
0.203.
0.203. What is the 2nd one?
0.495.
0.495. And somebody give me the 3rd one, please.
.3025.
303. How do you check that? What should all those equal? What does everything equal in probability?
1.
Is it 1?
Add them up and check them. They should equal 1. So your probability distribution, it looks like this. This is what you're going to see in the book. You're going to see event and the probability of an event. You may see X and you may see probability of X. Either one. Okay? And then over here, you're going to have 0, 1, 2, and we're going to have 0.203, 0.495, and 0.303. I want you to copy this. I want you to highlight it. And I want you to put a probability distribution right up under. That's what you're going to be studying in this first part of 6.1. Okay? Now, the reason I did this was to show you how you come about. Now, I'm not going to ask you to construct a probability distribution. That's what we just did. You need to write down constructing probability distribution. That's what we just did. I'm not going to ask you to construct. I'm going to ask you to be able to interpret this guy right here. All right? Now, there's two tests for a probability distribution. So that means the red marker's got to come out. I hardly ever write in red. When I do, that means you need to highlight. 1. The first thing that you got to check is that each probability is between 0 and what? 1. Each probability has to be between 0 and 1. Are all of our probabilities between 0 and 1? Well, 20 cents, 50 cents, 30 cents. Is that between 0 and $1? Yes. And then the second thing is all the probabilities should equal what when you add them up?
They all should equal 1.
It should equal 1. Write down those two tests. Because there will be one on the test that doesn't equal. I do put those on the test. And don't worry if this seems kind of confusing to you. Just concentrate on this guy right here. And this right here. Because that's what you're going to be given. This is what you're going to be given on a homework or test. I'm not going to ask you to do the math, but I wanted to show you how the math generates this. Anybody got a question on this one? What if you had 3 kids? Well, that would make it a whole lot bigger. That would make this a whole lot big. 0, 1, 2, and then what? 3. And then you'd have to write out that sample space of I told you to put it on in your index cards or whatever. I told you to go online and get it and put it on an index card like I told you to pull this one on for the one person that did it. That's why. Okay, so let's go back to the handy dandy. I'm sorry. There. Okay, so you're either going to have 1, 2, 3 events, and then the probability is going to be in terms of decimals, which is continuous. So on the left side, you're going to have events, and on the right side, you're going to have decimals, just like I showed you. You don't have to copy that. They don't have to copy that either. Okay, you can copy this one. Go ahead and copy this one because we might have some fun with this one if it equals 1. Go ahead and check. I've already checked the first test because I don't see any negatives and I don't see any whole numbers. So I need you to take your calculator and add up the probabilities and see if you get 1. I gotta get me something to drink.
I did.
Oh, good.
I got one.
Good. So now that you've got 1 as a total, we can either find the mean or the standard deviation. Now I want you to write down that's what your goal is for 6.1 probability distribution. That's what you're going to be tested on. Finding the mean and the standard deviation. So on the test, if you're given one of these problems, you're going to see a probability distribution just like this guy. They're going to ask you to find the mean. They may ask you to use the test. Is it a probability distribution? Whoa, what was that? Somebody turned their mic on or something?
My AirPod disconnected for some reason, and then reconnected. I don't know why.
Okay. All right. So I could give you one of two questions. I think I'll put this on the board. One question I could ask you if, oops, sorry, back up. How do I back up on this line? How do I back up? Oh, I know I can, but I don't know how, so I'm just going to use the backspace. Okay, let me hit my handy dandy white or black marker. I'm either going to ask you one, is it real? Okay, that could be a test question. Is it real? Meaning, is the probabilities between 0 and 1, and is the summation of the probabilities equal to 1? And y'all both said yes. So you could have a test question on my test, my unit 3 test from 6.1. I could ask you, is this a real probability distribution? And you would say, in this case, yes. The second type question I would ask you, and we'll do in just a minute, is I want the mean and the standard deviation. And I'm going to show you that in just a second. Now, while I'm going to just go ahead and go to the next. So there's 2 test questions out of 6.1 right there. Now, remember, I told you, this is not going to be, we're not going to spend a lot of time in 6 and 7. Maybe this week. I don't know, you're only 2 days a week, so we're going to try. All right? They're very, very simple. Next. And I've kind of put the slides in my order, so it should have, there it is, there's the 2 tests right here. Okay, is this a probability? No. 0.97. Is $97 million the same as $100 million?
No.
No.
Okay, 97 is not a dollar. So this, on a standardized test, this is what it would say. So write this down. I mean, you don't have to write it down. You can just wait and write it down if you watch the video again, or you can take a picture of it, or you can just say summation P of X equal to 0.97, put an X, because 0.97 does not equal 1. And then you got the gimme, the easy one. Why is this one easy?
Because it's less than 0.
Negative.
A negative?
Negative, less than 0, yes. That's an easy one. Or if this was 2.2. Okay, that's an easy one. And then, of course, the last one is 1. Okay? So there's your 3 possible test questions I could give you for, is this a probability distribution? And the reason I put those on the test is to just see if you're cognitive and you're self-aware, because if you miss one of those, don't what?
Tell anyone.
Don't tell anyone. Don't walk up to somebody. Mr. Yates, don't walk up to somebody and say, I missed that easy one on, is this a binomial distribution? Did you get it right? Don't do that, because the person you're talking to probably is going to walk away from you slowly. Okay? I'm not going to worry about this. If you want to graph it, that's fine, but do that in Excel or do it in your calculator. I don't know why you would, I don't know why, I don't know the reason for you to actually graph it. Okay, but maybe somebody in probability wants to make themselves look important, so there's no reason. I mean, honestly, you can see it right there. But anyway, that's how you graph it. There we go. Write down that formula. It's not a complicated, and when we do it on the Excel spreadsheet, you can do it by hand real easy. Go ahead and write that down. And the standard deviation is on the next slide. Okay, now the next one, I'm going to use this one, okay? Let me take my handy dandy highlighter. Don't write down the first one because that's just part of the derivation, okay? Y'all know what derivation is, right? How do you get the original? Okay, so I'm just going to highlight this one. There are some teachers that do use this one right here, but not many. We're going to use this one. Now remember, what is the relationship between the variance and the standard deviation? Somebody remind me, refresh my memory. What's the relationship between the variance and the standard deviation?
Priority 1 message
Square
coming in
root.
on secured channel.
Square root. Yes, you're right. Both of you are right. If you want the standard deviation, you take the square root of the variance. So under the radical is the variance. Question, right, complaint. Now we're going to do this in just a minute, and it's going to make a whole lot more sense to you, and I'll show you how to do it on the calculator too. Oops, sorry. Back. I got to figure out how to go backwards.
On secured channel.
I'm sorry, I got a bridge student texting me. I'm sorry. Okay, what's up? Backspace. There we go. And clear. Okay, so we're back to our old buddy, the probability distribution here. So I'm going to pull up my handy dandy Excel spreadsheet. Now, if you don't have a spreadsheet, go ahead and be punching it in your calculator under Stat, Edit. And I'm going to pull that up too. But I'm going to make this small right now so I can see both screens. All right, I'm just going to type in X. And that's going to be 0, 1. What is wrong with it? Okay, I guess my arrows don't work anymore. Let's try it. 0. Well, it wouldn't work. 1, 2, 3, 4, 5. And P of X, and some people call that P of E. E and P of E, I'm just letting you know, 0.06, 0.58, 0.22. Please work with me instead of against me. Hold on a minute. 0.58. I don't know why Can't be operator error. It's damn Russians. 0.01. Whenever something don't go your way in the real world, what do? Blame the what?
Russians.
Blame the Russians. Yeah, whenever something don't go your way, you blame the Russians. All right, so what do I do first? Well, it says the formula, I'm going to go back on the formula here. What does the formula say? Read the formula. I need to take X and multiply it by what?
You have a work email.
P of X. So I'm going to go over here and I'm going to say X times P of X. Everybody with me? Of course, that ain't. I'm about ready to quit. Okay. So I'm going to take that first one. I'll do the first one for you in my head. Let's see, 0 times 0.06 is 0.06, is 0, sorry. I'll do that in my head for you. That's some real, I just think, I'm not going to get anything to work right today. This times this. Thank you. Yes, I'm talking to my computer. And what does this say I'm going to do with X times P of X? What does that big funky E mean?
Sum.
Add them all up. Summation. Sum. So I'm going to go to home. Well, I got to make it bigger. And sum. And that is my mean. Write that down. That's how you do the mean. Now make sure you understand that. It's just one column. We'll highlight it green per day. Of course, everything's, I mean, it's like everything I hit today just doesn't work. Okay, I'm going to hit it again. What is wrong? Okay, the heck with it. I'm not going to. I didn't hit that. I didn't hit that. That's the fill button. Is that not the fill button? Okay, whatever. I mean, y'all see me hitting it.
Yeah, I don't know what's up with it.
Something's not hitting. Maybe y'all's is working. I don't know. Maybe y'all's. It's not supposed to turn off when I. Something's wrong. All right, so that's how you find the mean. Now I want to find the standard deviation. But first I got to pull up my formula, because the formula tells me what to do. Not Hubert, not calling up Hubert, not emailing Hubert. The formula right here. Somebody tell me what I need to do first in parentheses. Somebody tell me. There's only one set of parentheses right here. What I got to do? Come on, y'all can read. I want y'all to interact with me.
Multiply.
Multiply what?
X to the second power.
X squared and the
X to the
probability
second
of it.
power times what?
Probability of
Yeah.
X.
Probability of
Okay,
X.
so I've got to find X squared. We don't have a column that says X squared. So that means we got to what?
We got to make one.
Exactly. Thank you. I'm going to say this number raised to the second power. I'll do the first one for you. That's 0. I'll even do the second one for you. 1. Now, y'all said that we've got to take x squared and multiply it by what? The
By
probability
the
of x.
probability of x.
So I'm going to go here and I'm going to say x times p of x. I'm going to put equals, I'm sorry, x squared. Sorry, I messed up. Hold on. I don't want to tell y'all wrong. X squared. There we go. So equals x squared times p of x. And what do I do? Let's go back to the formula. The reason I'm going back and forth to the formula is because I want students to understand that the formula will tell you what to do. All you've got to do is what's that word? Starts with a R.
Read.
Read. Yeah. So what am I going to do with x squared times p of x? What does that big funky E mean? You're going to add them up.
Add them up.
That's it. It's hard to do when you got everything. Where is the formulas? Why can't I pull up the formulas? Shoot. I have to go back and forth, back and forth. Now I done lost my, I'm about ready to quit. Enter. And that right there is your number that goes right here. So I'm going to take my handy dandy. Well, I don't know why all of a sudden I can't highlight anything. Yeah, nothing will highlight. Oh, well, there's more than two ways to skin a cat. There, sir, you can go jump in a lake. There you go. That 3.09 is right there. Everybody with me? So what have I got to do to get my variance to that x squared times p of x summation, that 3.09? What do I need to do?
Take or subtract that.
The mean squared. So I'm going to go over here and I'm going to turn on my arrow and I'm going to put variance, because you will be asked on unit test, my unit test, homework, and the standardized test. They may not ask you for the standard deviation. They may ask you for the variance. So you need to know how to get it, and that's what's under the radical. So that's going to equal 3.09 3.09. It's like is working today. All right, I'm going to try it again. Equals 3.09 F9. I'll just have to do it that way. Minus parentheses 1.49 raised to the what? Second power. And that is your variance. And now what's my standard deviation? What do I do to get my standard deviation? I raise 0.8699 to the 1/2 power or 0.5 power. Or take the square root of it in your calculator. And that is, well, it should be highlighted green. Those are your three numbers that are most needed on a test. Now let's do it on the handy dandy calculator. Stat. Haven't changed gears here. Stat. And I'm going to type in 0, 1, 2, 3, 4, and 5. And go to the top of the next one. 0.06, 0.58, 0.22, 0.1, 0.03, and 0.01. Now I'm going to go to Stat, Calculate, and First Variable Statistic. Read L1 and L2, second 2, enter, and calculate. There's your X bar, 1.49, and your standard deviation, remember it's sigma, is equal to 0.9327. 0.9327, or 93268, 93268. We got the right answer. Let's try StatCrunch. Well, I have to pull it up separately. This ain't a homework problem. We'll try StatCrunch when we do a homework problem. Who's got it? Who's got a question on that? That's how you get the mean and the standard deviation. All right, let's do a nerd. I got one in here. I put one in here in the, we're getting ready for class. There's 1.49. We'll come back to expected value. I'm not worried about that right now. All right, do this one. Find the mean and standard. Is that the same one? I'm sorry. Okay, there it is. There's the standard deviation. I got another one. I think I do. Thought I did. Nope, I don't. Okay, let's go back to. All right, so now you got two questions I can give you on a test. One, is this a real binomial distribution? Two, what is the mean and standard deviation? And the three is called expected value. Write this down, expected value. This is basically when you find the mean of a short little sweet X and Y axes right here. Just like we did before with 5, but this only got 2. Okay? You survive or you what? You don't survive. Now read the question, and this is on standardized test. I probably will ask this one time on my test. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of a policyholder. That's the way insurance works. You die, your family gets the money. Everybody with me? Or ex-wife or whatever. These policies have premiums that must be paid. Premiums is a 25-cent word for payments. That must be paid annually. Most people have to pay every 6 months or every month. Suppose a life insurance company sells a $250,000 life insurance policy, 1-year term, to a 49-year-old female for $530. According to the National Vital Statistics Report, the probability the female will survive the year is 0.99791. Let me ask y'all a question. What if this was a guy? Would the life expectancy of a guy be higher or lower?
I'm going to say lower.
Why would you say lower?
Because insurance hates males.
No.
Because women use their brain.
Hold on a minute. The reason that guys have a lower life expectancy is because they're stupid. That's why.
Okay.
Does anybody want to see any more examples? We could see more
Yeah.
examples. if you
I
want.
live with a couple, so I'm good, Hubert.
Oh, you live with a couple? Okay,
Yep.
then you know how stupid they are.
That's an understatement.
And then you got your WWE the backyard WWE. We could put that in there. Backyard
That's just redneck.
WWE.
Yeah, that's what I was thinking.
Yeah, we got that. Well, you could run that if you want to. I didn't type it in the right place, but videos. Yeah. Table Battle Royal in the backyard. I don't think we need to watch that because somebody might get hurt. And then you got your jumping and old car in the woods. I wonder if I could find it. I can't find it. But anyway, there's a video of this guy that's got a ramp that goes like 60 degrees, and he jumps his car in the woods, and it lands on top of a tree, or right out on a tree limb, and he got it stuck in the tree. Anyway, so back to the question. That's me adding a little bit of humor to the class. Back to the question. Why does a woman have a higher expectancy than a man? Because men are typically stupid. All right, so if she survives, she's out $530 if we're talking from a person's perspective. But I need you to write this down. Write this down for this problem. Somebody tell me, are we looking in terms of the person or the life insurance company? Whose eyes are we looking through?
Life insurance company.
Okay. So she spends $530 and she has a 0.99791. So that means that the insurance company gets $530. That's why it's positive. All right, you need to put positive 530 because the question is in relation to the insurance company, not the person. If it was the person, would that be a positive 530 or a negative 530?
Negative.
Because that's a payment. Okay, a lot of people would say, well, that should be a negative because it's a payment. No, it's not. To the insurance company, it's money coming in. Insurance company. It doesn't say Bertha or whatever the woman's name is. It doesn't say compute the expected value of this policy to Bertha. If it was Bertha or Gertrude, then it would be negative 530. And what would the $250,000 be? Would it be a negative or a positive?
Positive.
If it was coming to
Positive.
Bertha. If it was coming to Bertha, that would be a positive, but it's not. So the insurance company gains $530. But if Bertha dies, they're out what? $249,470. Now make sure you make a note here. The reason that you're out $249 is because you took in $530 of her money. So that's why it's $249,470 negative. And that probability is the complement of this. The complement of 0.99791 to 1 is 0.00. What's the opposite of 98 cent? 2 cent. I'm sorry, 99 cent. 1 cent. Well, in this case, that's really almost 1. So that's the complement. Now just multiply that times that times that, and add it together. So the company is making technically an expected value of $7.50 per life insurance policy. Now, a lot of people say they only make $7. No, I didn't say that. I said the expected value of this life insurance policy is $7.50. They're taking in $530 every month, or every 6 months, or every year. How many people has life insurance? A lot or a few? A lot. So you take 530, you multiply that by 100. That's 530. That's 53. Let's see, 100. Yeah, that's 53,300 or 53,000. If you take 1,000, then that's going to be what? 530,000. If you sell 1,000,000 of them, or if you sell 500,000 of them, you start to see that 530 starts to count up. And what does those insurance companies do? Do they put that money in their pocket? Or do they invest it like banks do? They invest it like banks do. And that way, if let's say they sell 1,000 policies, they take that 530,000 and they invest it. And let's say they get up to 600,000. 600,000, they've made $70,000 off of the premiums that have come in, and that goes into account to pay for what? To pay for claims. I hope y'all don't think that banks and insurance companies just sit there with money in the bank and don't do anything with it. They invest it. If you think your money is sitting in a bank, just sitting in a safe somewhere, it's not. It's being played on the stock market. Just like a mutual fund, just like a CD, just like a 401k. Okay, anybody got a question on this one? Now, if it said, compute the expected value of this policy to Bertha, then this would be negative 530, and this would be positive 250, and it'd be a pretty big number here. And that would be because an insurance policy, is an insurance policy a gain to the person? Yes. Is it negative to the insurance company? Yes. They don't like to pick up the phone and hear the word claim. They don't like that. That's money out of their what? Out of their pocket. All right, so that's a test question. Make sure you make a note. Okay, now we're going into 6.2. Now, if I go into 6.2, there's two things that you've got to be able to do in 6.2. And I'm just going to use I'm not going to use, because I don't feel like getting up today. I'm going to pull up my handy dandy. Hold on a second. I'm in class, Carrie. I can't talk. That's my boss calling me. She knows I'm in class. Okay. So, let me text her and tell her that I'm teaching like I'm supposed to be teaching. Teaching. I gotta tell her something. Teaching in Math 120. Teaching.
Priority 1 message coming in on secured channel.
Oh, I hate when she does that. If you're going to talk to somebody, tell me what you're going to call me about. Don't just say call me. I can't stand when people do that. Okay. All right. Now, these are the two things that you have to do in 6.2. 6.2, you have to use NPX. And then the second part of 6.2, you have to use what we call just regular math. Mean is equal to NP, and standard deviation is equal to the square root of NPQ, which Q is equal to the complement of P. Okay. Over here, we're not going to use the formula for MPX. We're going to use what we call the calculator, binomial PDF for a particular point, and then binomial CDF for a cumulative point. And I'll explain that in just a minute. Okay, now I'm going to give y'all some things to write down, and then I'm going to call her and see what this is driving me crazy. I can't stand this. All right, here we go. I'm going to give her a call and see what's going on. And what I want you to write down is where is the, hold on just a minute. There we go. Be writing that down right quick. And I think, yeah, I'm going to find out what and I'll call, I'm going to mute y'all for just a second. And I'll get back with you in about 2 minutes. Sorry about that. It was about fall semester. She was telling me that she had to cut down my polycoms. So instead of my polycoms having 10 or 12 in each, it's going to have anywhere from 6 to 8. That's what she had to tell me. Okay, sorry about that.
We couldn't see the slide, Hubert. You forgot to change it back.
I suck. I might as well just forget. Might as well just quit. There we go. All right, now everything in 6.2, the first part, revolves around this. Now, I want you to write this down, and I want you to leave some room out to the right here, out to the right. Kind of put this on the left-hand side of the margin over here, and leave some room here to the right to draw a little number line. Okay? Because it's going to make a difference if you can draw your problem on a number line. So that's what I'm going to do, because I'm going to use my whiteboard. I think I might have enough room to write up there. No, I'm not. I know what I can do. I can shut y'all down. I'm going to shut y'all down. Look at there. And y'all will see nothing but white there. I'm sorry. Hold on. There we go. And I turn on my handy dandy current slide. Dang it. It still put black behind there. Wonder why. Oh, because I'm presenting in Teams. That's why. But I can change it back. I'm talking out loud, y'all. I don't know how I got messed up. There you go. I'll just leave this like this, and I'll draw my number line out to the side. Is that okay? All right. So, if you know what at least means, then you're okay. But if you don't know what at least means, you need to draw it on a number line. Now, most of these problems that you're talking about are going to be in respect to whole numbers. Okay, if I asked you about households, what is households in? Is there such thing as 1.5 households?
No.
No. So most of your problems with NPX is going to be with whole numbers. So that means that this number line is going to be 0, 1, 2, 3, 4, 5, and you might have a number like 5 households. At least means that the lowest number is that number. So at least 2. At least 2 means 2, 3, or there's 3 in there, sorry, and 5. Does everybody understand what at least means? At least means that the lowest number is that number or higher. That's what at least means. More than, or greater than, or fewer than, or less than means that you cannot include that number. 0, 1, 2, 3, 4, 5. If I say less than 3, if I say less than 3, that means 2, 1, and what? 0. If I say at most 5, that means that my largest number is what?
5.
5. So that means 5 and what?
5 and anything less
5
than
and below. Because your largest number is what? 5.
5.
So X, that's this guy right here, is dependent upon whether you know what the heck you're talking about with at least, at most, and less than or greater than. Now, n is always your what number? What is n always? N is always your biggest number. I've been saying that since the first week. Okay? N is always your biggest number. P is always your probability. Probability can be in the form of a percentage or a decimal. If it's in a percentage, you have to change it to a what? A decimal. And then X is going to be based on this right here. Now they're real easy. You don't have to do a lot of calculating. Okay? You're going to do it on your handy dandy calculator. So I'm going to go to the next so you can see what the formula is, and I want you to write down the formula because you're going to need it in case of a standardized test. They may ask you, what is the formula for binomial probability distribution? There it is. So write it down. I'll put it on current slide and trash. There we go. So write that down just for your information. There's your combination. This is a complement. That's Q. Remember, Q is equal to 1 minus P. So that's C NCX, P to the X, Q to the N minus X. Q is equal to 1 minus P. And some people write it CPQ. They put a Q right here. So let's go do an example. Here's an example right here. And I don't know why. Why do they do this? I don't want them to put. Hold on a minute. I might have something for this. Use my handy dandy tools. I bet they don't have. Yep. No. That's not what I was looking for. Give me a second. Write the question down. There it is. Oh, heck. There we go. There we go. I'm just playing, y'all. Y'all are impressed, I can tell. Aren't you? There you go. According to the Experian Automotive, 35% of all car towing households, there you go. Household means what? Whole numbers. Have 3 or more cars. 3 or more means 3, 4, 5, 6. But that's not what the question is going to ask. They're going to ask in a random sample of 20 cars owning households, what is the probability? Now, I want somebody to tell me what's the biggest number. Somebody tell me what the biggest number is.
20.
Somebody tell me what the percentage is.
35.
And somebody tell me what's left.
4.
4. And it says at least 4. So what I'm going to do is I'm going to take my handy dandy, hold on a second. I'm waiting. Number line. And I'm going to draw a number line. I'm going to put a dash there, 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 dash there. And we've got 20 cars, okay? So I'm going to put a little dot. I wonder if I can put a big dot. Let's see if I can put a big dot. I'm trying playing here. Let me move this up a little bit. If it'll let me move it up. I'm going to put a dot on at least 4. So that means the lowest number has to be what? 0, 1, 2, 3, 4. The lowest number is 4. Those 3 dots together means that I'm going to 20. Everybody with me? 0, 1, 2, 3, 4. So I'm going to take my handy dandy highlighter and I'm going to highlight this right here. Well, actually, let me hit undo. And I'm going to highlight at least 4. Now, is this important? Yes, it's very important because you're going to take away this right here. I'm going to do this in green. You're going to use the complement here because you don't want to go to, do y'all want to do a calculation NP4, NP5, NP6 up to 20? I don't want to. So I'm going to use the complement. What is the complement? The complement of 4 to 20 is what? 3 or less. This is the complement of this. So in this case, now, could y'all, Miss Billy, could you type in NP4, NP5 plus NP6 plus NP7 all the way up to 20? Could you do that if you wanted to?
Yes.
Yes, you could. All right. But Miss Woodward, being lazy as she is, she's not going to do that. What is Miss Woodward going to do? She's going to find the probability of 0, 1, 2, 3, and she's going to subtract that from 1.
Because it's easier.
Because it's easier, exactly. Now, there's a way you can do this real simple. Is there any spaces, any whole numbers between 0 and 3 not marked? No. So this is cumulative. Now let's see, sucks. Let me hit and put, ooh, I don't want to do that. There we go. Since in the blue, there is no whole numbers that have a gap, this is cumulative. So I'm going to do N, P, X, and in the calculator, I'm not going to do binomial PDF, I'm going to do binomial CDF. Cumulative means from the left, from 0, I'm going to add up 0, 1, 2, 3. And therefore, I won't have to do NP0 plus NP1 plus NP2 plus NP3. That's what the cumulative is for. Now, I'm going to do it both ways for you. Okay? So let's go to our handy-dandy calculator. And see if I can leave this up. And pull up my handy-dandy calculator. And clear. All right, here we go. Second, bars, VAR, which is right beside the clear button. And go down till you see binomial. And I'm going to pick CDF. Now I'm going to show you the other way. How many trials? 20. That's N. What is my decimal? Point what? And my value is 3. I want to go up to 3. 0, 1, 2, 3, because this is what? Cumulative. And hit paste. And it's what now, if you've got an older calculator, like a TI-83, and you hit binomial CDF, this is what it's going to look like. And you type in parentheses, 20, comma, 0.35, comma, 3, and close parentheses and hit enter. Now somebody write that down. That's up to 3. I'm going to bring in my handy dandy.
So Hubert, what is it? You said second, and what was the other button? I was trying to look for it on my calculator.
Bars, second bars, it's right beside the clear button. Hold on just a second, I'll show you. I'll show you again. Okay, so we want, here's the number line. And we've got 0 up to 20. And 1, 2, 3, 1, 2, 3, 4, 5, 6, dot, dot. And the question asks at least 4. Dot, 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 and then up to 20. So this is at least 4. And you could do 20.35 4 plus 20.35 5 plus 20.35 6, and keep doing that up until 20 and add those together. That's one way to do it. The other way is to subtract 3, at most 3, which is this one, this one, this one, and subtract that from 1. Or 1 minus binomial CDF of 20.35 and 3. Or you could do 1 minus, I'll do this in another color, 20.35 0 plus 20.35 1 plus 20.35 2 plus 20.35 and 3. And we're going to do that next. So I've got 1 minus, and my, let's see, hold on. Move this over here a little bit. I've got 1 minus 0.0444. And somebody do that for me. What do you get? Give me 4 digits. 0.9555.
0.9556.
Oh, thank you. Okay, so we're going to get the same thing when we do the blue part down here. So I want y'all to be punching in the blue part. Now you can do it with parentheses, or you can just write them down, or you can store. I don't care. I'm going to do it right now, and you can do it however I do it if you want to. So I'm going to clear this, and then I'm going to say, I'm going to go ahead and get all my numbers. I'm going to go ahead and get 0, 1, 2, and 3. So I'm going to hit, watch this. This is a trick I learned in the war. Hit second entry. Look up there. And then just arrow back and put in a 0. Hit enter. Now I'm going to save that as A. So I'm going to put an A right there. And hold on, let me show you what I'm doing while I'm doing it. I just put an A right there above that, and I'm going to stow that number. Where do you get bread? At stow. So I'm going to stow that number in alpha A. Of course, you can store it anywhere you want to. And then I'm going to hit second, enter, second, enter. Now I'm going to change it to 1. And I'm going to stow alpha B. Okay, I'm going to call that B on my paper. And I'm going to hit second, enter, second, enter. And I'm going to change that to a 2. Then I'm going to stow alpha C. Alpha C. I'm going to call that C. And then my last is going to be 3. Second, enter, second, enter. And I'm going to call that 3, enter. And I'm going to stow stow. I'm trying to find it. Hold on. Stow. I've got 23 things going around. Alpha D. That shouldn't be the same number. Huh. It shouldn't be. I don't know if this is going to come out the same or not. 1 minus parentheses alpha A plus alpha B plus alpha, oh shoot. Hold on, clear. 1 minus parentheses alpha A plus alpha B plus alpha C plus alpha D. Close parentheses, 0.9411. It shouldn't be that. I must have done something wrong. I've done something wrong. Anyway, you're not going to do it that way because it takes too much time. Okay, so the way you do it is you do 3 cumulative. Oh, I know why. Shouldn't have done that. I was doing cumulative. That's why. All right, let me do it again. I'm sorry. All right, go to second vars. And instead of hitting cumulative, I'm going to hit precise or point, which is P. Hit that. Now it's going to give me the right answer. All right, so I'm going to type in 26.35, and I'm going to type in 0. Now we're going to get the right answer. Okay, so hit enter. I'm going to stow that in alpha A. Stow alpha A. Enter. Now I can hit second enter. Second enter. I had the wrong formula in my memory. I had the CDF right here. My bad. Y'all should have said something. It's y'all's fault. 1. Stow alpha B. Okay. Second enter. Second enter. I'm going to do the next one 2. Yeah, these numbers look a whole lot better. Stow alpha C. And then 3, second enter. Second enter. And then 3 should not be what we got a while ago. Enter. Yeah, that looks a whole lot better. And stow alpha D. Now we're going to add them up. So clear 1 minus, oops, that's not a minus symbol, that's a negative symbol. There we go. Parentheses, alpha A plus alpha B plus alpha C plus alpha D. Close parentheses. And you should get 0.9556. 0.9, still not right. Okay, we ain't gonna worry about it. It should be 0.9556. I don't know why. I must have got something wrong somewhere. Wait a minute. 0, 1, 2, 3. That should be right. But use normal CDF. Let's do another one. Sorry about that. And they get 0.9556. We got 0.9556. They got another one next, so. All right, try that one. Okay, they don't have another one. I thought they did. Yeah, here we go. That's the one we just did. Oh, they went ahead and did it. There it is. Okay. Now, here is the last set of questions you're going to have in Chapter 6. And this is very simple. Okay, if you miss one of these, don't what? Don't tell anybody. Mean, I'm going to write it different. Mean is equal to N times P, and the variance is equal to NPQ. And what is the standard deviation to the variance? It's the square root. That's it. Okay? So, where's the example? Okay, I don't know if y'all gonna be able to handle this. This is some real deep math here. Write down that question. Yes, this is a test question. All these that I've done are test questions. According to the Experian blah, 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 blah. What am I going to do? What am I trying to find? Somebody tell me what I'm trying to find. Read and highlight those two words. Mean and what?
Standard deviation.
Standard deviation.
Okay, does it say probability?
No.
No. What did the previous question say? What is the what? Probability. Okay? The number one question I get in 6.2 is, how do we know when to do what? Well, when it says probability, you're going to use NPX. You're going to use your calculator. You're going to use binomial CDF or PDF, depending on the question. If it asks for mean and the standard deviation, then you're going to use NP and NPQ. So N is equal to 400. P is equal to 0.35. Somebody tell me what Q is equal to. What's 35 cents from $1? Oh my God. What is 35 cents from $1?
65 cents.
So Q is 65 cents. So here we go. And I'm trying to get out of this so I can show you. Now watch this. This is some real heavy stuff here. Mean is equal to 0.35 times 400. Wow, 10% of 400 is 40. 30% would be 120, and half of 40 is 20. That's 140. Somebody check me on a calculator, because a calculator is a whole lot better to use than your brain.
It's 140.
It's a miracle. All right, now I want you to find the variance. Well, you already got NP right there. So the variance is equal to 140 times 0.65. Well, 10% is 14. 14 times 6 is 64. Okay, just hold on a minute. And half of 64, 71. Somebody check my math.
91.
91.
I'm sorry. 91. Now, 84. 6 times 14 is 84, isn't it? Yeah, I said 64. Okay. Now, if the variance, oh gosh, yeah, I don't know if we can do this. 91. Wow, because 81 is 8. 81 is 9, and 100. 81 to 100 is 9. Half of 9 is 4.5. No. 81 to 100 is 19, right? 19, half of 19 is 8. 8 to 89. I'm going to say the standard deviation is equal to 9.6. Somebody take the square root of 91. What do you get?
9.539.
Oh my gosh, it's just a miracle. Do y'all realize I just did this without a calculator? You should be able to get started on it without a calculator, especially this. You should be able to take 30% of 400 in your head. And then 10% is 40, so 5% would be 20. You should be able to do that in your head. But that is your 2 questions out of 6.2. So let's write down what we've learned out of 6.1 and 6.2. 1. In 6.1, we learned that a binomial distribution, E and the probability of E, 0, 1, 2, 3, what do we get? I can't remember, 0.01, 0.5, 0.48, and 0.01. And each one of these has to be the questions on the test real. 2, they're going to ask you for the mean and the what? Standard deviation.
Hubert,
you
I
should
can't
be
see the top
able-
half of that.
I'm sorry, what?
Can't see the top half.
I got it. Okay, so out of 6.1, there's your 2 questions. Now remember, this could be 3 questions, you know, 1 being real, 1 not being real, and then the other one not being real. There could be 3 questions right there. And then 3, the life insurance slash, you know, mean, finding the mean of the life insurance policy. So that's 6.1. 6.2, make sure you know how to use NPX. And that is binomial PDF. And when do you use PDF, Hubert? I'm confused. You use PDF when it's pretty much what? Equal to. Like N is equal to 4, or P, or X, I'm sorry. If you get N is equal to 20, P is equal to 0.35, and they say X is equal to 5. If that's an equal sign, then you just use PDF. If it's less than, greater than, less than or equal to, greater than or equal to, if it's one of those type, then you probably are going to use a cumulative, which means up to or less than, binomial cumulative. And that's where you have to draw a number line so you can actually see what you need to see. Okay? So, and the other thing you're going to do in 6.2 is mean is equal to NP, and the variance is equal to NPQ. And of course, the directions here are going to say what? Probability. What are the directions here going to say? Mean and what? Standard deviation. So there are the 4, maybe 5 questions you're going to get for chapter 6. Two sections. Now we're going to take a minute. I know we're about finished. How much time we got? 10 minutes?
Yeah.
Somebody tell me.
Around that.
What?
It's about 10 to 15.
Okay. So what do we do in 7? Well, 7 is basically 2 type questions. Let me show you. Well, 3. The reason I want some of y'all have had probability and statistics before. So what I want y'all to do this weekend, or I'm sorry, before Thursday, I want you to go in and at least try to get some of chapter 6 and chapter 6.1 and 6.2. Get that going, sending in questions. Okay. Chapter 7 is 3 types of questions. I'm going to go ahead and show you what the questions are. First type question is called uniform distribution. Uniform distribution is used with time. Why is uniform distribution used with time? Does anybody have any idea? What's the one thing in the universe that we cannot control?
Time.
Yep. Well, although there are, you ever been to a cheerleading or a cheerleading or a dance recital? It's not, it's painful. It's really painful because some of the mothers try to control time. It's really sad. They wear their daughters' clothes and stuff like that. It's really sad. Anyway, we cannot control time. Nobody's ever been to a dance recital or a cheerleading. Mr. Yates, have you ever been to a dance recital or a cheerleading competition?
I've been to a dance recital.
You ever seen the mothers? Some of them, how they dress?
I
Yeah,
think I know what you're talking about.
Okay. It's in some cases it's pretty sad. All right.
They're trying to turn back time.
Exactly. There you go. Miss Billy, I can always rely on you. Okay? All
I call
right.
it Mirrors for America.
I can't hear you, Miss Woodward. What'd you say?
I said I call it Mirrors for America.
Yeah, is that what it's called? Well, I'm gonna be honest with you, it's not pretty. But anyway, the reason we can't control time gives us a graph of time that doesn't look like a curve. It looks like a what? A box. And the reason it looks like a box is because there's no variation. There's no variation because we can't control it. Okay? The area inside the box is just like the area under a curve, 1.000. Everything revolves around 1. You've got a base and you've got a what? A height. Some people call it length. Some people call it width. I don't care. Some people say base. Some people say width. I really don't care what you call it. Okay? They usually give you minutes from 0, let's say, to 50 minutes. They usually give you something like that. And if you were to solve this, area equals base times height. Area is 1 equals base, which in this case is 50, times h. So h is equal to 1 over 50. So this height is 1/50th. Now that's the way all your problems are going to be. This may be 0 to 60. It may be 0 to 30. It may be 0 to 10. And that will affect, and some problems already have the height solved. Okay, some don't, some do. That's how you get the height right here. Now what do you do? Well, the question will ask you, it will say, what is the probability, again, not mean, not standard deviation, what is the probability that the teacher will go past 40 minutes? Something like that. Well, you take your handy dandy orange marker, and where's 40? Somebody tell me where 40 is. It's right there. I'll even hatch it for you. So there's the probability that the teacher is going to go past 40 minutes. What if it said less than 40 minutes? What side would it be? It would be the left-hand side of 40 minutes. So somebody tell me, I need to figure the area of the orange rectangle. That's equal base times what? Equals base times height. Well, I know the height. The height is 1/50th. Somebody tell me what the base is of the orange rectangle.
10.
10. So 10 over 50. Hold on. I think I got this. I learned this trick in the war. 1/5, which is equal to 2/10. There's 2 questions on the test, just like this. I think one says 50 minutes. One may say 60. I think the other one says 30. And it takes a pick between them. That's how you do the first type question in chapter 7. Now, the reason I'm going through this real quick is because I know where most of the problems are going to come from. They're going to come from chapter 7, the second and third part that I'm fixing to go over. How much time have I got?
Got about 7 minutes.
Okay. The second and third type question in chapter 7 are going to be like this. As long as I got a good portion of Thursday to go over chapter 7, I'm good. Because usually I teach chapter 7 in a week and a half.
Hubert,
Conventional class.
if we're out at 2:30, I got 2 minutes on my watch.
Oh, so I thought, what time's class start and stop? Miss Billy, what time? You remember?
It's 12:30 to 2:35.
It's what?
12:30 to 2:35.
Okay. All right. So we've got.
See, Miss Woodward not paying attention like always, Hubert. I told you.
I'm sorry. You just hate me. That's what it is. That's all right. All right. So the second type question will be this type: normal distribution. Normal distribution will revolve around the normal curve. That means the empirical rule. I told you we were going to come back to the empirical rule in chapter 7. So that means you might want to get your drawings out with a mean of 0 and a standard deviation of 1. A mean of 0 and a standard deviation of 1. I'm going to take my highlighter and I'm going to highlight that because that's the difference between the two types of questions. So and they're going to ask you to find the area under the curve of a certain whatever. They're going to say, what is the probability of being less than -2? So they're wanting this area right here. And I'm going to show you how to get that area. Okay, because the area under the whole curve is 1.0000. Okay, I'm going to show you how to do that Thursday. And the third type question is normal distribution with mu equal to a number and standard deviation equal to another number. And again, normal distribution, empirical rule still stands. We're going to use it. That'll be 100. This will be 80. This will be 60. This will be 40. This will be 120, 140, and 160. And I may ask you in this section, find the test score that represents 65%. Find this test score. There are the three type questions, and we will go into chapter 7 Thursday. How about some of y'all that's had probability and statistics? Do y'all remember these type questions that I went over today?
So I don't.
Huh?
I said I've never had probs and stats before
Okay.
this, so I don't.
All right. How about some of you that had probability and stats? Anybody remember some of this stuff? Yes, no, maybe. Okay, so nobody in this class has had probability and stats. Nobody.
No, sir.
I don't believe that. I think somebody's not telling the truth or somebody's not talking. But I'm not
I
gonna
took pre-cal my senior year instead of prob and stats.
Well, good for you. That's what everybody should be doing. But they want to water everything down. I'm sorry. They want to put everybody in probability and statistics senior year.
That's what I had senior year, but my teacher was a coach, so he didn't really teach.
Oh, he didn't teach.
I've run into that a lot.
Okay, let's turn off the recording. Okay, right now I want you to be reading 6.1 through 6.2, 7.1, and 7.2. Once you read, if you got some time to try some in 6.1 and 6.2, go ahead and try some. Start sending some questions. You can try to start doing some in 7.1 and 7.2, but I don't see a lot of you doing that unless you've had probability and statistics before. Okay, and you can go on and dabble in it if you want to. So I'm going to stop the recording after that announcement, and I'm going to unpresent